because this is showing something entirely different. All right, good evening. Last month, we talked about the information of the cell, and it was pretty scientific, and I just want to give everybody heads up that today is a little more philosophical, so a little easier on the science for you. So we have this little saying here, which means life only comes from life, and we'll see that. Now, there's a lot of arguments about why the creationist model is correct, why we believe in at least a intelligent designer, if not the Bible itself. And so other scientists, we have books back here that written by Dembski and Stephen Meyer and so forth, that show that the improbability of life having spontaneously come about by itself, or what it's also called as abiogenesis. So we can look at, the handedness of the chemicals involved. We can look at the specific bonds that are required, and we can come up with some kind of number. And Dembski takes a little further and says, okay, so how much probabilistic resources do we have to deal with anyway, based on what's called Planck time, the distance it takes light to travel one Planck distance. And how many of those do we have from the supposed 13 point whatever billion years? And how many molecules or how many particles are there in the entire universe? And it turns out that you take all that as your probabilistic resource, and you still come up way, 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 way short. But because there is a possibility of it, the evolutionists will say, well, see, that proves it right there. Because there is a possibility, it must have happened. So, because after all, we do exist. And then later, Michael Behe and others come up with an idea called irreducible complexity, where that mousetrap must have a spring, a wire, a base, and all the parts that make it work, just as the flagellum on a bacteria must have its stator and rotor and the little thing that sticks out and makes it swim around. So it has to have all those things, but we're looking at the complexity in natural systems is what they look at, and that complexity are some things are irreducibly complex, others are apparently not, and so that leaves a back door that the naturalists will use to explain away why that's not true. So I'm looking today at irreducible structure, and this is based on the papers from Alex Williams, Royal Truman, and Pierre Terborg, and I'll just show you these real quick here. So here's Royal Truman and Pierre Terborg, their paper, Genetic Code Optimization, and then Alex Williams' Irreducible Structure, Autopoiesis. And this gives another way of looking at the impossibility, or what John von Neumann called the he didn't call it impossibility, he called it, see how many people were paying attention last month, the implausibility. Michael Polanyi, he argues that because of the form and function of the various parts of living organisms, those cannot be explained in terms of, that's what's meant by irreducible in this case. It cannot be explained in terms of physics and chemistry, and therefore it has irreducible structure. That's what we're looking at today. And he also wrote a whole paper on what he called tacit knowledge, which Doug Axe then picked up that, and that's what the premise of Undeniable is, looking at what he calls common sense or common science. And so these are all good things to have in your quiver as you go out to try and fight the enemy here. So the concept of life beginning through abiogenesis is considered an emergent property of matter. So just like if we have all of the conditions just right in the weather, we have the right temperature inversion, we have the storms coming together and causing the spinning motion and so forth, that eventually a tornado is going to emerge out of all of those conditions. And so some special arrangement that we don't normally see that come together, and because of that, then whatever thing emerges. And they believe that actually life is an emergent property of matter. That because we're here after all, so therefore we know there's no God, and therefore we know that it must be an emergent property of matter. Snowflakes are an emergent property of matter, and the things required to be emergent would be it's not dependent on any specific water molecule. You can add more water molecules, you can take away water molecules, and you're still going to get snowflakes under the correct emergent conditions. We can build them up one step at a time. So all of these things come together. We can reduce the formation of a snowflake to physics and chemistry of water, how the molecules interact in atmospheric conditions. A silver, little nugget of silver, chunk of silver, is mined out of the earth, and it has a certain crystal structure to it, and it's closely packed cubes. It's cubical crystal. And so it takes the shape that the earth around it allowed it to squeeze into. Over time, parts of it become black, and then, but all of that can be explained as emergent properties of chemistry and physics. On the other hand, when we look at the silver coin, we see that all those closely packed cubes of solid silver, to squirt that into a disc with images of men and animals and writing and women and all the other things, and now, you know, quarters, they put everything back in quarters. So it just goes on and on. We know that we can look at that and say that the coin is irreducible to the properties of physics and chemistry. We know that there must have been some external intelligent agent working on this piece of silver in order to convert it into this coin. We can see the design in it. And Polanyi would call that an irreducible structure is a naturalistic impossibility. So where do we get this autopoiesis word from? Well, if we look at Ephesians, the Bible says we are his workmanship. And if you look at the Greek, that word is poiesis. We are his poiesis. And autopoiesis means self. So we are, the concept of autopoiesis is self-workmanship. In other words, it made itself, it replicates itself, it sustains itself, continually regenerates and replicates. So interestingly, the idea of poiesis was hypothesized by Maturana and Gershenson and other scientists. And one of the things that Maturana said right off is never use poiesis to account for self-organization, because after all, operationally, that's impossible. So in other words, when we talk about autopoiesis, we know what they mean. They mean abiogenesis, something coming from nothing, and therefore, and then continuously replicating and sustaining itself. But the Maturana said, no. We don't want to make that claim, because everybody knows that's impossible. So I find that kind of interesting that they would say that. We can describe an autopoietic systems as those producing more of their own complexity than what the complexity produced by their environment. Of course, here he's obviously talking about specified complexity. Because to describe that silver molecule or silver that would be complex, but it's not a specified complexity. So self-sustaining and replicating, and we know they really also mean self-creating. But the idea of autopoiesis is universal in all living things. So because of that, it's universal in all living things. There's no backdoor from Michael Behe with irreducible complexity, because everything that's living has autopoiesis. It's inversely causal. That means that it actually, the thing that has autopoiesis actually goes out and does its own sustaining, rather than things happening to it. The autopoietic system will actually go and make it happen for itself. That would be considered inversely causal. It's information driven. It has a structured hierarchy. So those are things that an autopoietic system must contain. However, they also, this is Polanyi saying that there's an unabridgable abyss between the randomness of natural chemistry and the specified precision of biological processes. And we'll look at that in a minute. So there's levels of autopoiesis. Perfectly pure composition. You know, the cell has so many mechanisms in it that keep it absolutely pure. In fact, there are reactions that should be going on inside the cell, but because of the way the cell is wired and the way it's structured, these reactions don't occur, or they occur much more slowly inside the cell. There's just such, you know, molecular precision of every single thing that goes on in the cell. There's nothing accidental happening inside a cell. The next level, highly specific structure, that would, you know, we can look at a cell, and we just talked about the information system last month, the fact that we have the DNA, there's very specific machines that split apart the DNA and copy off the RNA. There's very specific pores that the RNA floats through, and very specific other machines that cap that RNA and then turn that RNA, or actually use that RNA to code for a protein. There's so many things that go on, and it's very functionally integrated. There's parts within it that all the parts have to be there working together simultaneously to make this machine work. Comprehensively regulated information process, information-driven process. Comprehensively means everything. Everything about the cell is regulated. There's nothing going on in there that shouldn't be happening. And then there's our word again, inversely causal. In other words, this cell is going to do whatever it can, or any living thing is going to do whatever it can to sustain itself and make the opportunities in order to go out and replicate itself and all the other things that it needs to do. Meta-informational strategies for individual and species survival. So we not only have just what's in the cell, but we have multicellular forms, and they have the ability, and even a single cell, the paramecium, knows how to swim around with its flagella and go find other life, more energy that it can derive from its environment for its survival. So each level builds on the level before, and this is where the idea of, or the analysis of autopoiesis comes to its height. So every level builds on its level below it, but it cannot be explained in terms of the level below it. I'm going to give some examples about this. And that's the irreducible or unbridgeable abyss of irreducible structure. So we have the perfectly pure composition and the natural environment, two totally, utterly different spaces that are unabridgeable between life and non-life. So putting this in a little more technical terms, the structure at a level n is dependent on the structure at level n-1. So the level below it is dependent on that level below it. but the structure at level n must be imposed by a level above, because in order to add something to one of the levels, there has to be something above that level to be able to add to it. The problem with abiogenesis is level n+1 doesn't exist. Can't get there. So genes only code for proteins, yet genes contain the genetic code that defines the organism. So each level of the structure within the autopoietic hierarchy depends on the level below it, but cannot be explained in terms of the level below it. So let's look at the vacuum cleaner. This is the evolution of the vacuum cleaner. So hopefully this will clear that up a little bit for you. So our first vacuum cleaner back in, I don't know, 1900 had a motor, housing, a fan, a dust bag, and a hose. That was your basic vacuum cleaner. It didn't even have wheels. So the operator, you know, she's just holding it just so gently. But really it was like moving this thing around. And then they finally put wheels on it and made it cyclonic. So it would actually suck the dirt out without beating up the fan so badly. And then that was kind of the vacuum cleaner for many years. And then the next level, we have a programmable robot, the little iRobot that goes around your house and sweeps up all your messes for you. And it has a rechargeable power source. So it's kind of neat because it'll, you put it in there, and then you go over and tell it when or now or whatever to do its cleaning. And then it'll go run its course, and if it gets low on battery, it'll run back to its full charge port and do that. So let's take that a step. That's where we are today. That's in our evolution of the vacuum cleaner. That's kind of where we are today. So imagine one that can sense when the floor gets dirty and just go clean it. So, hey, wouldn't that be nice? You don't even have to tell it. While we're at it, let's make it generate its own power source. Put a little nuclear power source on there or something, and then imagine that the next step would then be able that it can repair and maintain and replicate itself using the raw materials that it finds. So it goes through your house and picks up a little screw here, and you know, adds that, and it's wherever it needs it. And anyway, that's autopoiesis. So we have our vacuum cleaner now has finally become a life form. You know, it knows what it needs to do. It knows where to, or at least it has some kind of programming in it, how to go get what it needs in order to replicate and sustain itself. So the onboard self-power has to be imposed from a level above it. There was nothing at the level where it could self-power, and the only place that it could get that would be from a level above it. So the vacuum cleaner could sit there forever without being able to rid itself of the dependence on the outside source of power. Oh, stop. So that the power must be imposed from the level above it. It can't come from below it, because if it came from below it, then, well, it already existed, right? That's the only way it can come from below it. It has to come from above it. And it can't be at its level, or it already have it. That's the idea of irreducible structures in the levels. So the autopoiesis level is useless if there's no vacuum cleaner to repair or reproduce. So you not only have to have, you know, the new functionality, the autopoiesis functionality comes from a level above it, but if you don't have that level below to begin with, then you have nothing to build upon. So the levels are interdependent on each other. So the vacuum cleaner without the autopoietic capability can sit there forever without ever getting to the autopoietic stage. It must be imposed from the level below. Above cannot come from the level below. So let's take this into the simple cell. So the systems that it contains are not simple, but are foundational. So naturalism is backwards. Lower life exists to support higher life. Life is separated from non-life by this unabridgeable abyss of irreducible structure. All of the structures, all of the things that we see in the living cell had to come from some level above. In other words, we know that to be the designer. It's universal. Autopoiesis is universal in all things. Every living thing has the ability to seek out its own sustentation. Even viruses, they plug themselves into some cell and use that cell's DNA to do its dirty work. So it's a prerequisite for life, not an end process of natural selection. When abiogenesis started, when the first cell did whatever it was going to do in the naturalistic model, then it had to have all this in place. It couldn't just come up with it by itself because it didn't exist. It wasn't at that level. There's no alternative path. Without autopoiesis, life ceases to exist. So the fact, they're right. The fact we're here means that it had to have happened at some point. But we can see that it could not have happened because it would have required a level above. It couldn't have happened by itself. And so because it's universal to life, Behe's back door is off limits. We can't, nobody can say, well, but this thing. No, there is no but this thing. Everything requires it. Everything is living. Inversely causal, information driven, structured hierarchies, not reducible to the laws of physics and chemistry. There's a certain intelligence that is required for the cell to do anything. So it has to replicate itself. It has to make new proteins to do whatever it is that it needs that new protein for. It has to keep its energy flow going. It has to create ATP and do all that. So A is the cause of B, but B exists after, or A exists after B. The levels are intertwined. So DNA enables the proteins, but the proteins enable the DNA. The DNA is from whence the information comes in order to create the proteins, but that process itself is using DNA and rRNA. And then my favorite, of course, is the tRNA anticodons that are mapped to specific amino acids by the aminoacryl RNA synthetase molecules. And those are a collection of 20 different molecules, one for each of the amino acids. It's a double pointer system. So they must not only do that, but it has to correct select the correct chirality. It has to select or to create the right peptide bonds. It has to have the correct conformation. You may recall from last month that alpha helixes don't fold by themselves, yet alpha helixes are used a lot in life, in cells. So the unabridgeable abyss between the dirty mass action chemistry of the natural environment and the perfectly pure single molecule precision of biochemistry. Water is essential to life, but is also toxic. Hydrolysis breaks down bioorganic polymers. You may recall that the mRNA, when it first is created out of the DNA, that it has about 30 minutes to get capped. And then it's still only going to last about, half-life is 10 hours, even when it's been capped. The water will break that down. So the proteins, DNA, and RNA are polymers. Actually, the DNA and RNA are sugar polymers. The proteins are amino acid polymers, which is a mistake. Hey, on the first mistake. So water in the cell is hydrogen bonded as required for the function and survival of the polymers. So hydrolases are required to break down the polymers. After a polymer's been made, it only exists for a certain amount of time, and then it has to be remade or its functionality fades out. That's why it takes time to recover whenever you're sick, because all that has to work its way out. So raw materials in the environment, the air, the water, soil, are mixtures of just all kinds of contaminants and chemicals. And the processes that generate the biochemicals also generate toxins and useless isomers and useless bonds. Mass reaction versus single molecule precision. So that's kind of my presentation on autopoiesis. That make sense? Okay. Do you have any questions? Yes, sir. Yeah. Toxic in a general sense. Obviously, water has to be in the cell. There's a lot of reactions that require water, but when the polymers are created, when they're first synthesized, they either need to be capped or something, because if they're not, then they are going to be broken down by the water that's in there. The water creates all kinds of different bonds. It's highly polar, so it just heats up any polar bonds that are available. And, that's every time you wash your hands with water. And it's because the water will break down all those proteins and dirt that get onto your hands. And the same thing inside the cell. The cell requires that the way that the machine works is that there is a half-life of the polymers. So the DNA, the RNA, the protein all have half-lives. And that's, the machine has to keep making these polymers because they keep breaking down. Does that answer the question? No, Behe is not wrong. The naturalistic scientists use the fact that there are like some really obscure ways to kind of backdoor behind Behe to say, well, he is entirely wrong. But no, he's not wrong. It goes back to common sense science.
Human effort every so often seems that mind school and feel out anything to hurt it. And reproduce itself with another one like that. Go ahead and do this.
For billions of years. Yeah, has anybody made this machine outside of science fiction books? I'm not aware of any. Not even NASA. Yeah. Yeah, it'd be absolutely proof of intelligent design. Yeah, it's like the cartoon that's, we've all seen that. mRNA. Yeah, so that's the messenger RNA that the RNAP uses to synthesize protein. Yes.
And the water it's the lower energy level. The water fluxes into breaking apart and over time cause the water into it.
Right.
So this is a natural process. And you get a bunch of RNA, the mRNA and the RNA in water. And you try to make 10 hours go by and be
half as much.
No.
Yes, sir. Exactly. Exactly. Let me bounce off of that. We see that these are the amino acids. These are the polymer chains that proteins are made from. And we have a whole set of polar amino acids. Water, which was also designed by the creator, does something totally unexpected. it's H2O. There's an oxygen molecule, and then there's 2 hydrogen molecules. Now we would expect that the hydrogen molecules have like charges repel. We would expect them to be exactly on opposite sides of that oxygen, but they're not. They're at 120 degrees. And so because of that, we now have one side of each water molecule is a little more negative, and the other side is a little more positive. It has, you know, a little bit of attraction to everything it comes into contact with. And so all of these polar amino acids, the serine, threonine, cytosine, tyrosine, all of those are actually going to react with water probably more readily than they're going to react with anything else, because, you know, the amino and the carboxyl are what join the peptide that make that the chain of the protein polymer. But believe me, they would the polar side of them would much rather react with water than they would ever want to react with making a peptide bond. That's a pretty expensive bond. Capped RNA is 10 hours. Yes, sir. Uncapped is about 30 minutes. Yeah, so yes, a long time before they would ever want to bond to themselves. Trying to find that slide here. Yeah, there we go. Okay. So after the RNA comes out of the nuclear pore, it's stabilized. So there's a machine called poly A, and that's one of those mitrons. It's a little machine that it's literally in a circle, and it just continually runs, and it joins the adenine bases to protect the 3' tail. And then there's a 7-methyl gualiate. I'm more of an astronomer than a chemist. Joins on to the 5' linkage. So it gets capped on both ends. Without that, the ends are going to unravel. There's also caps on the DNA called telomeres. And if the DNA doesn't have enough telomeres, it'll begin to unravel as well. And then you got a really big problem. And that's called old age. That's kind of what happens. As you get older, your telomeres, you know, become shorter and shorter. Yeah, one of the things. Exactly. Any other questions? 10 hours? Yeah, well, there's things in the cell, or in the chemistry and so forth of the cell, the structure of the cell, that keep all of the water busy. So in the cell, put in a glass of water, it may be much quicker, maybe, especially those polar, and really, for that matter, the acid and the base are also where it Yeah, that 30 minutes, that's like best case. Yeah. Yeah. It's like every time you come up with some little scenario to improve some little part of it, you've just destroyed every other part of it. That's kind of the way it works, unfortunately for them. The oxygen, yeah, is highly reactive. Oxygen is highly reactive. So that's why, originally they thought it was reducing atmosphere. In other words, oxygen free. And then it created that thing. Yeah, so I mean, basically you have to have a little laboratory of some sort where parts of what's needed are synthesized and then stored and not allowed to degrade, and then at the right time mixed with the other parts inside some type of membrane that's going, some little bubble that's going to protect it all so it doesn't break down and instantaneously. And by the way, you need the right chirality, you need the right bonds, and
you can understand chirality because the way the DNA is structured is from only two members fit. But before the first step,
yeah,
when you're in the environment that you can't control, you look at the DNA. The sugars are all right-handed sugars.
right.
All 10 million. And we go into the proteins could not have been made by the DNA before the cell. So these proteins have got to also be there to make the DNA work. They got to be formed. And yet there's already chirality there because all the amino acids are all left-handed.
Left-handed, yeah.
And then when you look at the cell membrane, they're all left-handed. 200 million. So how did this chirality occur before the first cell finally encapsulated with that? They all had to be there, and all that chirality had already exist at the closing of that membrane.
Right.
It's impossibility of impossible. And that you think is play there's formation of DNA.
It would react.
And destroy it. It wouldn't be a functional. Totally random. And there's no way to fight it. That's exactly right. You can have the left-hand sugars in there, but now the molecule will not be a helix. It'll buckle. And now it's a non-functional DNA, which doesn't. So what I'm saying is there had to be chirality all the way up and down the line, but that 3 billion strands of DNA with every sugar on the 2 strands. So that's like 6 billion sugars, all right-handed to make the ladder, the size of the ladder. And then at the same time, we've got proteins that have got to be in certain little things like proteins that are going to make energy, all that stuff. And all of those are left-handed amino acids that could not have been formed since they were the first cell. So look at all that chirality. Every one of those is left-handed. That don't happen. And then there's the membrane that's got to swallow all of it. 200 million of them for the smallest cell. 200 million of them. And they're all left-handed. Are you kidding me? I would stop playing these things. I've recently heard James Stewart. Origin of life, why they deal with this problem, because there are various times notice these are huge problems that they need to do something about it. And for one thing, the ring of muscle memory is brilliant. Sure, gave us get to a very, very modest result. Then go short one time, you know, this is really pretty. Let's go back to the start of this. Where do you get them? Where you got them? And they all had to be powerful. And the question I didn't get to answer is, they know how to make it, or they can. How we break it down. That's the process. That's the process that they would make.
Undirected process. Right.
When I say that's not
Right. That's why. That's why I went ahead and.
so the raw material before there was life, otherwise protein.
Right. The trick is that the shape of the molecule determines the function of that molecule in life. And so if you've joined enough left-handed or enough right-handed, whichever, and then somewhere along there you have the opposite chirality, the wrong-handedness, then you get a kink, and the kink will never work. Yeah. Do I have that? It's just that it's, yeah, that's fine. So the amino acids, for instance, remember the drawing we just had? We had the amine, we had the carboxyl, we had the hydrogen, there's a carbon in the middle, and then the whatever that defines that, the reagent, no, it's not the reagent, the residue. And so we could have, you know, the carboxyl and the amine are what makes that's what gets bonded in the peptide bond. And so look, you can see we can have left-handed or we could have it in right-handed. So we could have, you know, have it on the opposite side. And the molecule itself is kind of like a V. So part of it bends, you know, this way, and the other part bends backwards. It's a little hard to do, in case you're wondering. And so that's why I'm not, you know, giving you that live long and prosper here. But that's why the molecules, they have to fold. You know, it's the function determines, or the shape absolutely determines the function. And if it's not folded properly, or in the case of the sugars of DNA or RNA, if they don't link with the correct nucleotide bond, then they're going to be twisted around the wrong way. And in the case of nucleotides, they are read by the RNAP by grabbing a hold of those triplets that make up the codon. And so if one of them's turned the wrong way, it's not going to plug in right. So it's never going to work unless it's plugged in correct.
As long as it wasn't near the active site, or as long as they had that was zero. Now, obviously, rather large molecules, but they never got more than 1%. Never got 1%, and that still had anything.
Right, and that's what Doug Axe. That's what Doug Axe is. That's his research.
But because it was far enough from the active site, that the ability to act. But you couldn't get more than you can get 1%. 1% became non-functional.
Non-functional.
It's a really tiny percentage. So what they couldn't do was get the 40, 50, 60% change that you get from plant cells and animals. They couldn't actually make that. They could make a tiny little plant, make a tiny little rodent, make a tiny little animal. They couldn't actually far enough in their experiment, no matter what they did, far enough. And they did end up with a whole lot of that's
Not correctly folded proteins. And
one of the arguments they'll make is, well, look,
exactly. Anybody else? Mm-hmm. Okay. I haven't been there, but what about it? Oh, they show the sugar. Oh, okay. Yeah, there was an experiment one time when they made left-handed sugar. And the idea was that you couldn't gain weight because your body won't use left-handed sugar. So it was one of those artificial sweeteners that was actually sugar, but it used the left-handed. The problem was that it also wasn't digestible. And so it missed it by that much. Yeah. Uh-oh.
and 2 months later, people were getting weight because it hit the brain and
Oh,
it shut the brain down. You stop. And at first they didn't know what causes it. Bodybuilders, something died here, you know. They traced it to that man-made protein.
Which used 50% chirality.
Tried to do it all by chemistry, very cheap. And
yeah, I think I remember hearing about that. So, yes, sir.
needle if your animal is out of air and he will die. So that is what a little bit of air in the wrong place will do for a very healthy organism. And so our atmosphere is all air and open water to it. These are both toxic things that we need.
Yeah, it's the right stuff in the wrong place. Get you every time. All right, my conclusion. I have a conclusion. This is part of a 7-part series, so the autopoiesis part is obviously not the whole thing. So how should we then evangelize? Francis Schaeffer wrote a book, How Should We Then Live? So he who wins souls is wise. We know that. I think, and this is just my opinion here, but I think that, you know, having an us versus them attitude may not be that healthy. For one thing, I believed in evolution. So you're going to write me off? I hope not. So we see that atheism, evolution, Darwinism, whatever you want to call it, is based on material and physical. Whereas God, creationism, salvation is based on the scripture and the metaphysical, beyond the physical. Few things that I find that are not effective is to say, well, my Bible says, because the problem is that my spiritual trumps your material when you're talking to an atheist. Well, there is no spiritual, so they don't care. My book says that your science is wrong. It's really a non-starter. Another thing that you hear people say is that the fool has said in his heart there is no God. You go back and look at the Hebrew, for one thing, the fool in this case is one who's devoid of spiritual discernment. In a way, it's a little bit of a tautology. But the material, physical man cannot discern spiritual stuff. So naturally, it's going to be foolishness. So I think it's better to confront sinners with their sin. That's the formula for salvation, and not the impossibility of their theory. People need salvation. Science is kind of optional, even though I'm obviously very involved in science. Things you can ask an atheist, you know, where did all this stuff come from? Well, but they do have an answer, at least they think they do. It came from nowhere. And somehow that satisfies the atheist. It's a little hard to swallow, but we're here, and therefore, you know, back to that argument again. So if life is ultimately meaningless, why are you arguing? Well, because they believe in what they believe in. It is a religion, after all, and they're arguing because, well, for one thing, religion on this planet has caused a lot of damage in the past. And hopefully not as much today, especially hopefully not as much in the Christian realm. But kind of hard to argue against the fact that, you know, religion has caused some problems. It's caused also a lot of good in the world. At least at one time, all the hospitals and things, institutions that were really helping people were all Christian at one point. But still, from an atheist standpoint, that can be a problem. Right, yeah, it was the Inquisition, the Crusades, and all that. Yeah, I mean, it was man's flawed philosophy, not the theology of the Bible by any stretch. So, yes. So if the material world is all there is, how do non-material, such as logic and truth and information, exist? Well, they just do. So I'm not sure that's all that good of an answer. But we do know that the origin of life is the origin of information. Everybody agrees with that. Information is non-material. So when we talk about material things, and then we talk about life, there is always a metamaterial component there. Same thing with information requires intelligence. Intelligence is also non-material. So you kind of can get your nose under the tent, as they say, get your foot in the door with looking at the things that are absolutely non-material. Complexity comes from greater complexity. So information in life requires an intelligent designer. What we just talked about, the autopoiesis, the levels of autopoiesis. Darwin's tree of life increases complexity. Now that is, I think a lot of atheists or evolutionists, I think they really do kind of, in the back of their mind, you know, that is a question that is hard for them to answer. Now, one thing they'll say, well, if God made life and life is too complex to evolve, well, then God doesn't exist either. Right? I mean, well, think about it. So, which is less likely, a machine or the designer of the machine? You know, it's kind of, okay, I can kind of see that. So physical life is too complex to have evolved by naturalistic, undirected means. But God is a metaphysical spirit. And so that kind of answers that question. Life, or logic, truth, and information exist outside the material. We just talked about that. So what exists outside of our material universe? If there are things that can exist outside the material, we have a material universe. What exists outside of that? And again, we're just getting our nose under the tent, just to open their minds to the fact that there are things other than the material. In the ancient scripture, there are, you know, the Bible is a history book. It's not a science book. Okay? Hopefully you knew that. But where it talks about science, it's right. Atoms are invisible. Blood clots peak on the 8th day. The spherical earth hangs in space. I hate this flat earth thing. I wish they'd get over it. Pi equals 3.14 in 1 Kings 7:15. Sorry. I mean, look it up. You can see. Do the math in First King. Bible talks about wind currents, water cycle. Job 40 talks about the apatosaurus, not an elephant. Okay. The Cambrian explosion and punctuated equilibrium. Well, God made it. So the game plan, let God's Spirit guide you, because He wants this person saved more than you. Whoever it is that you're witnessing to right now, whatever atheist or non-atheist, for that, well, I guess in a way everybody doesn't believe is an atheist. But anyway, God sent His Son to die for this person. Are you willing to die for them? Probably not. Maybe for a good man, someone would die, but God sent His Son to die for it. God wants them saved more than you do. And so keep that in mind. Let the Spirit guide you. Study science. Answers in Genesis, Creation Museum, ICR, hey, GHCAonline.com. Study soteriology, in other words, salvation. That's the theology of salvation. Living Waters, The Way of the Master. That's Ray Comfort. LeafNet and scriptel.org. That's my good friend, Mr. Leaf. So what about the evolution worldview? Too little time for life to evolve. You look at all of the statistical analysis, there's just not enough time. So then they invent these little saving ideas where, well, okay, so we have a multitude of universes and they all have time. Or, you know, it's the Big Bang and then followed by the big squish and then followed by another Big Bang, followed by another big squish. And so that's how they get all the time that they need. But there's too many irreducible complexities and structures. And the irreducible structure, I think, is a stronger argument than even irreducible complexity. Matter tends toward disorganization. You know, look at your teenager's room, you know, find that out right away. Information is non-material, requires intelligence, and yet information is in the cell. So build a bridge. Can't do just drive-by evangelism. I don't think that helps anybody. Really build a relationship with people. Right now, I'm, you know, working at an observatory, building a relationship with the other astronomers there, and they don't even know I'm Young Earth Creations. They will one day, but it'll be a one-on-one thing. I have to show them how much I care. I show up when, you know, I even miss church a few times. To show up on Wednesday nights. After this, I'm probably going to go by the observatory because they're working on doing an alignment. So show them how much that you care. Our worldview is that the Bible teaches that the world, life, the universe, and everything was created in 6 24-hour days. That's everything. A day is the word yom in Hebrew. Yom can mean periods of time. It can mean, like, you know, we talk about day, how we use the word day. Well, same in the Hebrew. Yet when the word yom is used with the word evening, or used with the word morning, or used as a first, second, third, fourth, the cardinal number, then it is always, in the other 400 times that the word yom is used, it means a 24-hour day. It's very clear that it means 24-hour day. The author of Genesis 1 went out of his way to make sure we understand that the first evening and morning were the first day. Every day is a 24-hour period. Only one period of light, one period of dark. Okay. One morning. Yes, right. It's right. It's a single. Doesn't refer to the days and nights. No, it's the days, the mornings and evenings. Okay, spoken by the PhD in it. So our worldview, we believe not just in Genesis 1, Genesis 2, but 3 and 4 and 5 and 6, and certainly 1 through 11 are the foundation of the rest of the Bible. Every theology that is in the Bible is in Genesis 1 through 11. So Adam's sin brought death to the human race and a curse to the world. And through that, mankind waxed evil and God judged. And that judgment was the Noetic flood, which was not a little local flood, it was a worldwide flood. And so what would we expect to see from a worldwide flood? Billions of dead things laid down in rock layers all over by water all over the world. So, and what do we find? Billions of dead things in rock layers laid down by water all over the world. So God led Noah to save his family in every kind. Not every species, every kind. Jesus Christ was fully God, yet fully man, and died for the sin. And being God, an infinite being, he had the ability to die once for all. And resurrected, not just died, but resurrected, thus proving himself to be God. Tempter Satan will be thrown in a lake of fire with everyone who rejects God's gift of salvation. New heaven and earth will be created for everyone who, by God's grace, turns from their sin to holy living and accepts Jesus Christ as Lord. So in the last days, there will be scoffers saying, where is everything? Everything's been the same since the beginning. Uniformitarianism. It's predicted by Peter, of all people. And in 2 Timothy, Genesis 1 through 11 is the foundation for every doctrine in the Bible. And Jesus, we know, will return soon. People need salvation more than they need science. Science is very important. And we need to be able to have not just an apology for the faith that we have, but also an apology for the science that we believe in, because that seems to be a really big stumbling block for a lot of people. But God is not slack concerning his promise. Long-suffering, not willing that any should perish. So we know that God sent his son, made the ultimate sacrifice to die as substitution for our sins, and he wants that all should repent. So the Big Bang is 2 Peter 3:10. The day of the Lord shall come as a thief in the night, which the heavens will pass away with a great noise. That's my Big Bang. Not yours. There was. Okay. That's another Big Bang theory. So thank you for your attention, and thank you for having me, and look forward to coming back possibly one day.
Find out if it's recording.
So we're done? Any questions? Any more questions? Go ahead. Oh, have a thought. That'll work too.
The part of fully man, fully God, so that before he resurrected, after he died, different from man, so that he didn't go to sleep, but he ascended.
His body completely died.
Yes, but
Yeah, what we saw.
his soul was not asleep. I say he ascended. Present, but like, because when we die, when he comes back, we see in the body.
Yeah, actually, that's right. On which? Oh, pi. Let me back up here. 7:15. Yeah, it talks about how wide to make it and the circumference of it. And keep in mind that the brim was 1 hand breadth wide. That way you get a better it's actually 3.14 if you use 3.14. Exactly. Yeah. Otherwise, you just get 3. But if you remember the hand breadth, which is part of the specification, then it is 3.14. Really? Okay. Yikes. Yes, sir. Yeah. Yeah, there's plenty of references to stars. Yeah. I like to show people the Pleiades, especially at the observatory, especially the past few months. It's been really high in the sky. And in Japanese, the word, what we call the Pleiades in Japanese is called Subaru. And if you look at the symbol for the Subaru car, it's Pleiades. And then I go on about how the Bible mentions Pleiades too. So, but really, Bible? It's in the Bible? Yeah, go look it up. No, it's who placed Orion in the Pleiades. So, references to God. Yeah, I don't have it memorized. It does. One of my favorite things to photograph is the Orion Nebula. And the Pleiades, for that matter. Anything else? Thank you, Matt and family, for coming. Some more members of our church.